Okay, so at the start of the trig equations unit, we're going to cover inverse trigonometry, which is something that you've actually been doing for a little while now. Every time you look at a unit circle and you say, hey, the sine of an angle, theta, equals 1/2, what's that angle? Every time you say that and answer it with something like this, well, sine of 30 degrees equals 1/2, right, from a unit circle. See this arrow guy I've pointed there? Sine of 30 degrees equals 1/2, so the answer is 30 degrees. Well, you're doing inverse trigonometry right there. You're going backwards. You're saying, here's the result of my function. What's the angle that produced that? Here's the problem, though. You could also say sine of 150 degrees equals 1/2. And if you wanted to go into the coterminal angles, you could say sine of 390 degrees equals 1/2. Okay, these are all true statements. In fact, there's an infinite number of angles that would satisfy this equation, and that is a problem because sometimes we just want a simple answer. I say, what's the inverse sine of this thing? And I would like just one answer. So that is why, see this picture I have here? That is why in this picture, I'm only going to talk about inverse sines as coming from two quadrants, quadrant 1 and quadrant 4. That way, whatever the angle is that you get, there's only going to be one answer. Okay, the y values, if you look at sine as being the y coordinates, they're all unique. There's no repeat y values until you head over into quadrant 2. See, in quadrant 2, you got a repeat y value right over here. That's one of those repeat angles that we want to avoid. So for that reason, traditionally, when you're answering the inverse sine of something, you give one number and you use quadrants 1 and quadrants 4 to find your inverse trig or your inverse sine function. Now, it's the same for tangents. You can see inverse tangents also come from quadrants 1 and 4. But inverse cosine is different because cosine is the x values. You could have a situation, well, let me draw this in red, be consistent here. If I was looking up the cosine values of something, I would get a repeat. See, the x value right here is the same x coordinate. So for that reason, we limit the cosine values to be only in quadrants 1 and 2 when we talk about angles. And that simple idea of not wanting to repeat myself when I answer a question is what leads to this problem in your homework. This is another way of thinking about it called domain and range. We're familiar with domain and range, but it might be easier for you. You can think about this in terms of graphing inverse trig functions. If you've done that already, that would be ideal, actually. But I know many of you have not, so you might think about it this way. Sine of y equals x. Well, domain, remember, domain is your x values. And range is your y values. And what sort of values go into a sine function? Well, those have to be angles. So those are things like 30 degrees. Domain is the result of your sine function. And those are numbers like, I'll just call them regular numbers. Okay, for lack of a better word. Regular numbers. These are things like 1, square root of 2 over 2, etc. Now, in terms of the angles you can put into the sine function, the range, okay, you can see a few options here. That's an angle, that's an angle, that's an angle. Those are good angles. These other ones, those are not angles. So you should be able to see right away that those can't be the range. We only have 3 choices here for the range. And what angles go into a sine function? Well, I just mentioned that earlier. Quadrants 1 and 4. Okay, so if I have my sine function right here, I'm taking the inverse sine of something. I want to know what the range is. Let me see if I can circle the right thing. Come on. There we go. The range of the inverse sine function. Well, that's quadrants 1 and 4, which is this right here. Whereas if you're talking about tangent, remember tangent is the same quadrants, but we have to watch out for domain restrictions here. Domain restrictions at pi over 2 and negative pi over 2. Those are DNEs. So we modify our range a little bit for the tangent function to use curvy parentheses. And with the cosine function, because that's quadrants 1 and 2, let's see, keep getting distracted by the domain. The cosine function is quadrants 1 and 2, that's 0 through pi. Now the domain is everything that is the result of taking the sine of an angle. And if you think about cosine and sine, the only things you're getting when you take the cosine or sine of an angle is some number between -1 and 1. Okay, it's always going to be between -1 and 1. It might even be those values, -1 and 1, which is why we have hard brackets or square brackets. Whereas tangent is this kind of funny thing where you can actually get any result from a tangent function. It doesn't have to be limited to -1 and 1. It could be 10, it could be 100,000, right? Tangents, if you remember what the graph of a tangent function looks like, this may help. They have asymptotes in them, and they go down to -infinity on one side and up to positive infinity on the other. So that's why your tangent values are not actually limited to 1 and -1 and everything in between. So that's the idea with domain and range. You could make an argument like this for the reciprocal functions also, but I don't think we're going to get into that.